Hello guys, so let's carry on the integration part that we were working on, and today we will talk about integration by parts, an extremely important one. It's a methodology wherein you try to find out integral of actually a product. Let's understand what it is all about. In fact, to understand the working of by parts, what you need to recall, if you remember differentiation and you remember the product rule of differentiation. So the product rule of differentiation says that if I want to find out d by dx of product of two functions uv, then it is u multiplied by derivative of v plus v multiplied by derivative of u, right? So now if we integrate on both the sides, what's going to happen? So integration and differentiation, they are entire of each other. So clearly, when I integrate uv, d by dx of uv, I'll just get uv, right? So when I will integrate on both the sides, what I'm going to get is uv is equal to integral of u into dv by dx plus integral of v into du by dx. Okay. So all we've done is we've just integrated on both the sides. That is it. We've just integrated on both the sides. Or what I can do is I can just rewrite this. So let's rewrite this. So this would be, that means we are talking about integral of u into dv upon dx is equal to uv minus integral v into du upon dx. So I can rewrite and write it like this also, right? Now, herein, if you take u as some function fx and you take dv by dx as some function, see, derivative of some function will also turn out to be a function, even if it's a constant function, but it will turn out to be a function, right? So let's take dv upon dx as some function gx. Then essentially what do we have? We have that then du upon dx is nothing but f dash x, du upon dx is nothing but f dash x, and v is nothing but, since dv upon dx is equal to gx, then v is nothing but its integral of gx, right? So we can say that's what we have, right? So if we take u as some function fx and dv upon dx as some function gx, then du by dx is f dash x and v is equal to integral gx. So this expression, what does this expression turns into now? Let me call this expression 1. This expression 1 turns into, this implies that integral of fx, since u is fx into gx dx is equal to fx into v is what? Integral of gx dx minus integral, the whole integral of v. V is integral of gx dx. That's v into the derivative of u. So that is f dash x dx. That is f dash x dx. du by dx is f dash x dx. Or in other words, finally, if I write it down, let me just write it down. That is, what do we get? We get integral fx into gx dx. Integral of this is equal to fx times integral gx dx minus integral of the whole thing together, integral of the product f dash x into integral gx dx, the integral of the entire of this thing, this product here. This is what is integration by parts. Now you will have to, with questions, you can practice and figure out what should I take as my fx, what should I take as my gx. So that's what we understand with some examples. So what you need to understand is we call fx as the first function. We'll call fx as the first function. I will generally mark it 1. Gx as the second function. Second function. And I will mark it as, Roman 2. Okay. So you mark it as 1 and 2. So you're talking about integral. Integral of 1 into 2 dx is equal to 1 as it is, integral of second minus whole integral, the derivative of first into the whole integral, okay, of this product into the integral of second whole dx. That's what you will try to find out when you are using by parts. Examples. So let me just take you through few examples. So let's understand. Suppose I have to integrate x cos x. Now in x cos x, let me take x as 1 and cos x as 2. Okay. So let's take x as 1 and cos x as 2. So that means this integral will be 1 as it is, integral of second is sin x, minus whole integral, derivative of first, which is just 1, into integral of second, which is just sin x dx. So that means I will get x sin x minus the integral of sin x is cos x. The integral of sin x is minus cos x. So this will be integral of sin x, which will be minus cos x. So cos x plus c. So the correct answer would be that you are taking, you're getting x sin x plus cos x plus some constant c. Okay. Now, herein, suppose I would have taken in integral x cos x, I would have taken this as 1 and this as 2. Then what would have happened? Then we would have complicated the situation for ourselves. How? Because this integral would have been cos x as it is, first as it is, integral of the second is x square upon 2 minus whole integral, derivative of the first, which is minus sin x into the integral of second, which is again x square upon 2 whole integral, right? In other words, we would have got cos x, x square by 2 cos x minus plus integral of sin x, x square by 2. Do you think we would be able to find a solution like this? No, we will actually just complicate our situation. So it's very important. With this example, I just wanted to tell you that it's very important to choose your first and second function correctly. You need to choose. See, remember, I'm giving you a trick from my side. Remember that in this formulation, what do we have to do? We have to find out the derivative of first, right? This is a hint from my side. Whether you find it in any book or not, that's another thing altogether. But generally, since you're differentiating the first function, so first function should be taken in such a manner that when you differentiate it, instead of complicating the term, it simplifies it. For example, when I took x as the first, when you differentiate it, you just get a constant one. But instead of that, if you take cos x as your first one, if you take cos x as your first one, when you will differentiate it, you will get sine. Then if there is sine, then and you take sine as your first one, you will differentiate, you will get cos, and it will be like a never ending process, right? So in general, you should choose the first one, which you differentiate. When you differentiate, it simplifies the scenario. Okay. So few things that we must note down here. Number one, it's not applicable every time. By parts is not a solution to all the problems. For example, if you have to integrate square root of x sine x dx. Now square root of sine x, square root of x into sine x. Square root of x into sine x is such a term for which you have no function which is a derivative of it. There is no function available whose derivative is root x sine x. There is no function available whose derivative is root x sine x. If there is no function available whose derivative is root x sine x, then how do I integrate root x sine x? There has to be a relation, right? There has to be a relation, right? So number two, that's number one. So you can't, number one is basically you can't apply it everywhere to all the functions just like that randomly. Number two, notice that we do not add any constant. We do not add any constant while integrating the second function. You are integrating the second function. You are choosing first, second, and then you are integrating the second function. But if you noticed in x cos x, I never wrote that plus c. I just wrote plus c at the end. And the reason behind it is that it is a superfluous situation. It will just give us a superfluous value. It is of no use, putting a constant beforehand. Let's take again, just try to redo that and you will realize what I'm trying to say here. Integral x cos x dx is equal to, if I do write a constant sin x plus k, then it will be x into sin x plus k minus integral sin x plus k dx, right? So this would give us x sin x plus kx minus, when you will just integrate this, you will get cos x. Integral of sin x is minus cos x. So minus minus plus cos x minus integral of k is kx plus, again you will have a constant. So which essentially means that, what do I get at the end? This and this just cancels. I get x sin x plus cos x plus c. I'm getting the same answer. I don't need to take a constant inside. Okay. So when you are integrating the second function, you don't have to take that constant. Okay. At the end, you will be writing down the constant. So as I said, the hint that I gave you, that in general, that's my experience. The first function, since we have to differentiate it in between, should be that kind of function which simplifies after differentiation. So if any function is a power of x, is x square, x cube, or it's a polynomial in x, we generally take that as the first function. We generally take that as the first function, okay? And in case you have inverse trigonometric, if inverse trigonometric function or a log function is there, then that has to be taken in. Then these as the first function. These have to be taken as the first function, okay? Let's now work on a couple of examples. Suppose we have to integrate log x dx. Just integrate log x dx. How would you do that? Now, integrating log x. Integrating log x is a special case in itself. You just have log x here. You don't have product of two functions, but log x could be taken as log x into 1. Constant 1. So what I can do is I can take it as integral log x into 1 dx. And let me take log x as 1. As I said, log, in case log is available, then log has to be the 1. That has to be the first function. And 1 as the second function. So this would be log x as it is, integral of 1 dx minus whole integral, derivative of log x is 1 by x into integral of 1 dx, whole dx, okay? So which means that I'm going to get log x into x plus, not plus, minus integral of 1 by x into x dx. So this cancels and you get x log x log x. Integral of 1 is just x, so minus x plus c. So x log x minus x plus c. The integral of log x is x log x minus x plus c, because the derivative of this is log x. So hence this is the correct answer, and that's how we have used by parts in it. Next question, x into e to the power x. X into e to the power x. So here what we will do, we will take x as 1 and e to the power x as 2. We always take exponential as the second function. That is because if you take it as the first function and you differentiate it, you will keep on getting ex again and again. So again, it will not simplify your situation, it will make it complicated. It might just complicate it. So this is 1, this is 2. So 1 as it is, integral of dx minus whole integral, derivative of x is simply 1 into integral of ex dx whole dx again. So this will be x into ex, because integral of ex is also ex, minus whole integral of ex dx. So it will be x e to the power x minus e to the power x plus c. And that's what will be the correct answer. And that's how you find it. Let's take another example here. Let's take the example x sine inverse x upon square root of 1 minus x squared. Let's see how we can work at it. What should I take as the first function and what should I take as the second function? Okay, so let's take the first function as inverse. I said inverse trigonometry. In case that is there, you should take that as your first function. So let's take first function as sine inverse x and the remaining part. So let me just separately write it. 1 is sine inverse x and 2 I'm taking as x upon square root of 1 minus x squared. Okay. So we would require integral of the second. So let's just do that. So that means we would require integral of x upon square root of 1 minus x square dx. And clearly, can you notice that you will have to use substitution here? So let's just use substitution. Put x square, 1 minus x square as t. So that implies minus 2x dx is equal to dt. So hence, what do you get? Integral of the second one is essentially integral minus 1 upon 2 minus 1 upon 2. Let's just substitute in here. So minus 1 upon 2 dt upon square root of t, right? Square root of t, which will give you as a result minus square root of t, right? Which means that what do I get? I get minus 1 minus square root of 1 minus x square. Okay, so that's your integral of second, which we would require in between. That is why I just figured it out. And what else you would require? You would require the derivative of sine inverse x, which is 1 upon square root of 1 minus x square. Okay, so you would require d by dx of sine inverse x, which is 1 upon square root of 1 minus x square. So we have what we require for by parts. So therefore, the integral of x sine inverse x upon square root of 1 minus x square dx is equal to 1 as it is the integral of second minus whole integral derivative of first into the integral of second whole integral again. So we will get sine inverse x into minus square root of 1 minus x square minus whole integral derivative is 1 upon square root of 1 minus x square into minus square root of 1 minus x square. Wow. So what do I have here? I have things cancelling. So you have things cancelling here. So that means what I actually get is sine inverse x into minus of square root of this minus plus integral of 1 dx. So it is basically minus of square root of 1 minus x square sine inverse x plus c, which would be the correct answer. Okay, so this would be the correct answer. Let's take another example. Integral of e to the power x sine x. Integral of e to the power x sine x. Let us this time take ex as our first function. Let us take ex as our first function. I know I told you that ex should generally be taken at the last, but the competition is between ex and sine x. So ex can be taken as the first function here and sine x as the second function. I would suggest that you can try out taking sine x as first and ex as second also. So try that out. Are we getting any answer, correct answer with that or not? Just check it out for yourself. Let me take ex as first this time. So if I take ex as first, I would require the derivative of ex, which is just ex. And I would require the integral of sine x, which is minus cos x. So pretty simple. This would be, according to by parts, this I'm going to quote it as this integral as so I is equal to, now this one is for I and this is Roman 1 and 2, first and second, okay. This is integral I is equal to, first as it is, integral of sine x dx, I could have directly written, minus The derivative of ex is ex only, integral of sine x dx, the whole dx, right? So it's going to be ex minus cos x plus integral ex cos x dx. Minus minus made it plus, so that is why I've written first, plus there. Okay. Now, this is what I get. What I can do next here. What I can do next here. What we just figured out here, this expression consists of another integral, which is pretty much like the integral we are dealing with. So what I'm going to do is, I'm going to take this as, say, I1. So let's calculate I1. I1 would be, it is integral of ex cos x. So it's going to be ex as it is. Integral of cos x is sin x minus derivative of ex is ex into integral of cos x is sin x dx. Oh dear. So what do we get here? So we get our original question within this. So what we can say is this is nothing but I. So let's just substitute back. So we have in this I, we have I equals to minus e to the power x cos x minus, no, not minus, plus e to the power x sin x minus integral, or why should I write the integral? Minus I, which means that I can take this I out here, and this will give me twice of I is equal to minus e to the power x cos x plus e to the power x sin x. Which means that finally what I can say is that I is equal to ex by 2 sin x minus cos x plus c. The constant value has to be added, so I can add it at the end, plus c. So this is what you get as your I using the integral or original integral once again. So that's how you can calculate this kind of a function, integral of this kind of a function. This should be the final answer. My request to you, just check it out the other way. If you take ex as second and what did we start with? Sin x as the first, then what's going to happen?